Hey guys, Mr. Milton here. Today we're going to look at multiplication properties of exponents. Number 2 notes. At the end of this video, you should be able to use multiplication properties of exponents to simplify exponential expressions, and you should be able to differentiate between various properties and use them to accurately simplify expressions. Okay, so from last lesson, remember that we were able to basically simplify multiplying bases with the same exponent. Remember, they had to have the same base. So there's one base and I don't know, however many exponents. Okay, here's our new stuff. Okay, remember that we can only do this if the bases were the same with our exponents. When we were multiplying, when our operation was multiplication between them, then we could simply shortcut and say it was the addition or the sum of these two. Okay, so new stuff. It says rewrite the following expression so that the property above can be used. So we have x to the fourth cubed. Okay, so it looks kind of funky because we have exponents to an exponent, but cubed just means we're repeating that multiplication 3 times. So we have x to the fourth times x to the fourth times x to the fourth. Okay, using the old property we know that this simplifies to 4 plus 4 plus 4, same base. So it gives us x to the 12th. Okay, so new property, our base still works only when it's the same base. So it has to be the same base, there's only one base. But how many exponents now is going to be our, to find out how many exponents there are going to be, it's going to be our product. It's going to be m times n, okay? Exponent to an exponent. So let's see how that looks here. We have 3 to the 5th to the 4th power. Our shortcut tells us, all right, we have one base still, all right? Our exponents, since we're raising the exponent to the exponent, is 3 to the 5 times 4. 3 to the 20th power. Okay, now typically if we can simplify it, we will. With this, if we're going to do 3 to the 20th power, that's going to be a super high number, okay? This is like, what, 9, 10 digits? We don't have to type that in, okay? So we can just leave 3 to the 20th power as 3 to the 20th power and use your kind of common sense to realize when numbers are too large when we're raising them to a power. Okay, here we have b to the negative 4th times, or to this negative 2nd power. Okay, so raising a power to a power just means we're going to multiply these exponents. And so we end up with b to the 8th. Our multiplication rules are pretty consistent. Negative times negative is positive. Okay, so we're good. Number 3, we have m to the 6th times m to the negative 4th. A couple things to notice is that we're not raising a power to a power here. Okay, we have m to the 6th plus negative 4, so minus 4. This gives us m squared. Notice the difference between 3 and 2. 2, we're raising a power to a power. There's not a second base here. 3, we do have that second base. This is multiplication and not using exponents. Number 4, we have c to the 5th to the negative 3rd power. So we have c to the 5 times negative 3. And so we have c to the negative 15. But remember, that can't be our final answer. We have a negative exponent. We don't want that. So we need to move it down to the denominator so it can be happy. Okay? And so 1 over c to the 15th is how we should write our final answer. For number 5, we have k to the 6th squared times k to the 5th. Okay, our order of operations comes into play here because we want to do parentheses and exponents first. So we'll make this k to the 6th times 2 times k to the 5th. And that gives us k to the 12th is 5. Our answer here is k to the 17th. Okay, number 6, as you look at that, See, it's in a different order, but our order of operations still tells us what to do first. We need to do exponents first. Okay, so we have x to the negative 7th times 2. And over here we'll have x to the 3rd. So x to the negative 14. And that gives us x to the negative 11. Remember, our final answer cannot have a negative exponent. We'll move that down to the denominator and make it 1 over x to the 11th. This is what happens when there are more in the parentheses. Well, so if we have 5x cubed squared, let's see what that would mean for us. That would mean we'd have 5x cubed times 5x cubed. Okay? And so we've done these problems before, right? We organized it so that we said, okay, well, let's put our 5s together because we know they multiply. Let's put our x cubes together because we know we can multiply those. And that gives me 25x to the 6th. Okay, here is how we can do this. Remember that each number has an exponent. So what we can do here is when we have this exponent to the outside, we're going to distribute it to the exponents on the inside of the parentheses. And remembering that each number has an exponent, I'm going to put 1 by 5. So I distribute this over, and I distribute to each of these terms. So I have 5 squared times x to the 3 times 2. Oops. And so that gives me 25x to the 6th, the same thing that we got by rewriting it and multiplying it like we know we can. Okay, so let's do a few practice problems with that here. So 2z to the 4th, I'm going to make sure that each of my numbers has an exponent, and then I'm going to distribute to it. So I have 2 to the 4th, z to the 4th. That's going to give me 16 z to the 4th. Number 2, I'm going to distribute this 2. So I have 3 squared g to the negative 10. This negative needs to move to the denominator. 3 squared I can simplify to give me 9. So 9 over g to the 10th. Number 3, 2 doesn't have a written exponent, so I'm going to make sure I write that 1 there so I don't forget to distribute to the 2. So 2 to the 3rd power over, nope, not over, I'm sorry. 2 to the 3rd power, t to the 0 power, because 3 times 0 is 0, or yeah. So t to the 0 power simplifies to 1. So I have 2 to the 3rd times 1 now. That's just 8. Number 4, you might see this right away and be like, well, why is he doing all this? I just want to show you. We'd have 2 to the 0 power, t to the 0 power, 1 times 1, which is 1. Again, anything to the 0 power is 1. Number 5, I'm going to follow my order of operations and do my exponents first. Okay, so I'm going to distribute my exponents to these terms. And so I have 3 to the 3rd power c to the 15th. Okay, and that simplifies to give me 27. Remember to do 3 to the 3rd power, not 3 times 3. So now I'm here. It's a multiplication problem. I'm going to organize. So I have 27 c to the 6th plus 15. So I have 27 c to the 21st power. Number 6, distribute this 5 to the powers inside. So I have 2 to the 5th power, a to the 8th power. Oops, not 8. I'm multiplying to the 15th power. Make sure I write these, distribute this to each of the terms inside. Boom, boom, boom. So I have 3 to the 3rd power, a to the 3rd power, b to the 6th power. Okay? And now I need to reorganize this, and before I do, I want to make sure I have some actual numbers for this. So 2 to the 5th power gives me 32. 3 to the third power gives me 27. All right. I have 8 to the 15th, 8 to the third. So I'll have 32 times 27, a to the 15th plus 3 because we're multiplying those, and then b to the 6th. There's no other b's. All right, double check and make sure I included everything. All right, 32 times 27 gives me 864. 864, a to the 18th, b to the 6th. Okay, number 7. Making sure I put this 1 all over all these things so I don't forget to distribute to it. So I have negative 5 to the third, m to the third, n to the third on this side. I have 4 squared, m to the negative 6. Okay, I'll reorganize these. This gives me negative 125 and 16. Okay, m to the third minus 6, n to the third, right, because this is 16. All right, so now as I multiply those together, 125 and 16 gives me 2,000. So it'll be negative 2,000. Okay, this gives me m to the negative third. It's a negative exponent, so I need to move that down to the bottom. So it'll be over m to the third and then n to the third. And so here's my final answer. Remember, we can have negative numbers in the numerator. We cannot have negative exponents. Okay, in our last problem, we're distributing a negative exponent. So I'm going to distribute that 1 over, I'll have 2 to the negative third, x to the negative 18, y to the positive 12. Okay, looking at these exponents, negative 3 and its attachment, x and its, they need to go up. So I have 2 to the third up top, which gives me, I'll just take those steps, 2 to the third, x to the 18th, y to the 12th. So I have 8 x to the 18th over y to the 12th. All right? Now, let's see how that works with scientific notation, because if we can do it with letters and variables, then we can do it with numbers. So we follow the same process. We could follow the same process, okay, and distribute this to both terms. So 3.1 squared times, and it'll be 10 to the 16th. So this gives us 9.61 times 10 to the 16th, and it's already in scientific notation. Okay. The other way that you can do this, rather than using the shortcut, is that you can just say, hey, we're squaring something. That means that we just multiply something by itself. Okay. And so I can do 5 times 5 and 10 to the negative 6 times negative 6. Okay, and so that gives me, in this case, 25 times 10 to the negative 12. Okay, we want to make sure that we write our answer in scientific notation. So I'm going to move this over, 2.5. I made this number smaller, so I need to make this number bigger. Okay. And that's what happens. 2.5 times 10 to the negative 11. Remember that scientific notation is the only time we can have a negative exponent. All right, and there we have it. Multiplication properties of exponents number 2. See ya.